So today we're talking about something a little bit different than what we've been doing. We've been doing a lot of converting between moles and mass and parts and all that. What we're going to look at today is percent composition. And percent composition is the percent by mass of each element present in a compound. Our math for this is actually pretty simple. We're going to get back into finding our molar masses, and our formula is going to be the mass of the element over the mass of the compound and if we want to get that into a percent and not just a decimal, what are we going to have to do? How do we go from, because this will just give us a fraction or a decimal, how are we going to get that to be percent form?
Times 100.
Times 100.
And that did not fit on there.
So yeah, it should be all one line. We'll rework it.
So, well, I like to go part over the whole times 100.
Right, which really just means the same thing. The mass of the element, the whole we're looking at, is the mass of the compound. Both are perfectly valid ways to look at it.
Okay.
All right, let's do a problem together like this.
Alright, so we're going to do H2O first.
So, we said, what did we need first?
We need our hydrogens, and we need our oxygens, and we need their mass.
We need their mass. So, the mass of one hydrogen, we have to look on the periodic table, is going to be 1.01. What are my units on that?
Grams.
Grams, because we're assuming we have a mole of it.
Yay.
All right, and then my mass of one oxygen
is 15, right?
Actually, it's 15.999, so let's just do 16. Make our lives easier.
Oh, okay.
All right, and our units are grams again.
Grams, okay, but we had two hydrogens,
So,
we need to take that into account.
all right,
So it's going to be about 2.
so 2.02 if we want to be particular. All right, so we know we have 2.02 grams of hydrogen and 16 grams of oxygen. What do we need to do with that to find our total?
Our molar mass total, we're going to add them together. Plus 2.02 will give us 18.02 grams total.
So that's our whole, and then our parts are our individual elements. This is where it's actually really nice if you do your molar mass the long way and find each element, because then you've already got your parts and it's easier. All right.
Okay.
So we're going to do part over whole.
If we're looking for our hydrogens, we're going to do 2.02 over our total of 18.02 times 100.
So we're going to plug that in our calculator. So we have 2.02 divided by 18.02, and that's going to get us 11.2%.
But then we multiply by 100.
No, it gets us
you did
0.112, and I multiplied it in my head. Sorry.
I was like, 2, right?
11.2%. Generally, when we're doing, usually I tell you go to 2 decimal places. If we're doing percentages, 1 is generally as far as we need to go.
More than enough. Okay, and then we're going to do oxygens percent, which is going to be 16 divided by 18.02 times 100. I shouldn't actually look at the calculator.
All right, and so we are going to get 88%. 88.8 actually.
8%.
And what do you notice about our percent composition of hydrogen and our percent composition of oxygen?
If you add them up, they equal 100%.
Right. This is how we know that we've done what we need to do, because the whole compound together is 100% of the compound. So all of your parts should add up to 100. Sometimes it won't be quite there because of rounding, but it should be pretty close.
Which is a logic issue.
Yes. All right. So let's try our guided practice.
Okay.
All right. So this one's a little bit different, because earlier we were getting our formula, we found our molar mass.
Right.
Here, what does it tell us?
It's already giving us a mass.
So it's giving us the mass of our parts.
Right.
So what's our part for barium?
Our part for barium is going to be 95 grams.
Okay. And then what does it tell us about our fluorine?
And our fluorine is going to be 26.3 grams.
So those are both of our parts. How are we going to get our whole?
I need to add them.
We need to add them up. And that gets us 121.3 grams for our total mass of our compound.
Okay.
All right, so now to do percent.
Okay, so my percent of barium is going to be 95 divided by 121.3 times 100.
And that's going to get us 78.3%.
All right, and then I do it for fluorine. So 26.3 divided by 121.3 times 100.
And that's going to get us 21.7%.
Okay, just to check my work, if I add those up,
We get
yeah,
100%. Everything works out. Hopefully that's not too awkward. All right, so let's try one more guided practice problem together.
All right, last one.
Calculate the percent composition of potassium sulfate. Ooh, this one's mean. Because what are we going to have to do first?
Because I have to write my formula first.
We have to write our formula. So potassium is
K.
K, and it has what kind of charge?
Plus 1.
Plus 1. And then sulfate, we're going to look up on our polyatomic ion page because it ends in 8 and not "ide."
So that is SO4.
With a
2 charge, right?
-2 charge, yep. And what do we do with the charges?
Crisscross.
We crisscross.
So K2SO4.
All right, so now we're going to do just like we've done on our others. So break up into our separate elements.
K, S, and O.
All right, so our mass of K is going to be 39.10 grams per mole times how many do we have?
I have 2,
Okay,
which gives us
78.2 grams.
grams.
All right, and our S is 32.07. And how many of that do we have?
1.
So we don't have to multiply by anything.
I'm going to write it just so that they're all in line.
Nice. We just want to make it pretty.
Because it makes me happy.
All right, and then O is basically 16.
We're going to do 16.
Yep, times how many do we got?
4.
And so our total mass of all our oxygen together
4.
is 64.
Okay.
All
So
right.
that's each one. I need a total.
78.2 plus 32.07 plus 64. So my total mass is 174.27. All right. So now to do percent composition.
Total. Okay, so
Parts over whole.
for my K, I've got 78.2 divided by 174.27 times 100. Put that into our handy dandy calculator.
And we get 44.9%.
And then we'll do our S, 32.07 divided by 174.27 times 100.
And we're going to get 18.4%.
And then my oxygen, I'm going to write it up here, is 64 divided by 174.27 times 100.
And so that's going to be 36.7%.
I just got right off the screen.
All right, and so if we add 44.9 plus 18.4 plus 36.7, we get 100%.
Exactly.
So we've got,
Yay.
all right, so now you can move on to your practice on this. Not so bad.
Not so bad.